So at the rear of the wheelbase, you can see we are using the optic encoder, which features 23 bits. And at the front of it, we got a slip ring that just get the USB connections all the way to the front. So you can use something like this. This one is an adapter, and you can mount it here, all before the quick release.
Let's just start that. So you got the encoder, you got 23 bits, right?
Yes.
What does 23-bit give you over, say, 21-bit, or what advantage do you get with 23?
I would say it's more about the optical sensor instead of the hall sensor itself, because for the optical, all you have to do is to mount it on the shaft, and it does not get disruption from all the magnetic fields from the motor when it's running.
So it could be more accurate. Right?
Yes, it can be more accurate and free of the because will always be some mounting errors between the two. And for optical sensors, it's free of them. And basically, you won't have any trouble with the dust inside. It just works really good.
Okay,
and,
so just to explain, so we've got the optical sensor. So what happens when the shaft is moving? So the magnets are moving the shaft, right? The magnets are controlled.
Yes.
The electromagnets.
Yes.
They move the shaft very quickly and responsively, right?
Correct.
20 Newton meters. And then what mechanically is happening here? What is spinning? When the shaft is spinning, when my wheel is turning?
The optical sensor is fixed.
Okay.
And then the shaft is spinning.
So it senses the shaft.
So it senses the shaft. Within. All happens within.
So that's all happening at the back. So it detects how the shaft is spinning, etc.
Yes,
and then it goes back to the controller.
detect its position and to use 23 bits of the resolution, it can go even smoother.
So the motor gets an instruction to move the shaft.
Yes.
And then the optical controller is assessing it.
Yes.
And feeding back into the. Is that something that happens?
Correct.
Yeah.
So basically, here we will have a control board. And with all the power blocks, which is basically used for the motor control. The motor control board together with the control side to the PC. So that's the PCB assembly over here. And at the front, we will have a cover. And together with a front shell, which is coming over here. And the front shell is made of die casting aluminum, which will take some heat also from the motors.
So it vents the heat out.
It will also help with the cooling. So basically, we do not have an active cooling system.
Just the material.
Yes, it's all from the metal that is transferred its heat to the outside.
So some brands have a style where they have channels in it.
Yes.
This one doesn't. Is that necessary to have channels, or is this fine for?
It's just already fine for the thermal controls, because we did tons of labs to make sure that it can take what it takes. Basically, if we are testing platinum, we are running it at 20 Newton meters maximum in the game for 4 hours of time span, which is a long, very, very long stint. If you are into the endurance race.
So that's what you test at?
Yes, and after 4 hours of maximum 20 Newton meters, the torque drop will be less than 5%.
Okay.
Yes.
And just explain the slip ring as well. Like, what's the purpose of the slip ring here? Because we can see the shaft can move in it.
Yes.
So what's the purpose? What's going on here?
So basically, this part, the sleeve of the slip ring, it will be just fixed. And so the cables won't be strangled everywhere, and so you just have one of the cables out here for the connection of the quick release. So basically, here you connect the quick release system, and you get all the connections, USB connections for the wheel. So you plug this one in, and you plug this little thing to your wheel, like we are having one of these here. This one is 290 GP. And there will be a connector here, and you just plug it in.
So you get all the data coming through, and then coming out into the USB.
Yes. So basically, the PCB assembly, it will also work as a USB hub. So integrated USB hub.
Yeah.
And it just gets the devices from the slip ring.
Yeah.
And so you only have one cable out to the PC. Then it will recognize your serial.
So I can charge my phone here. I can have a light as well.
You can, because the output is quite enough.
Oh, really?
For the charging the phone.
Okay.
It is 5 volts and 2 amps.
So what we need is like a MagSafe on the end, right? And then your phone's going to be going like.
You can do it. Yeah. You can even print. You can even show an image of the stereo if you want on your phone.
Yeah. Maybe for diagnostics. That's really cool. Is there anything else about this that people may not realize? I mean, what about the magnets here and the coils?
The magnets here. Okay, so I not be able to pulling that off because it's too strong to take it off. But I can go through them a bit. So basically what we have in here is a dual screw pole motor.
Yeah.
We have the rotor side, which is screw pole.
Yeah.
You need to align the magnets in kind of not inlined.
Yeah.
You made it a bit offset, so it just rips off all the cogging torque from the PSMMs.
Yeah.
So basically, alongside we are having the stator, also featuring the offset.
Yeah.
So alongside the way it works like this, and it will just eventually eliminate the cogging torque that you don't want, because in sim racing, I would say it's all about authentic feedbacks. And I think the philosophy we are having there is that we want to make it 100% sure that people are getting what the game developer is transferring to the force feedback system. Because I know the people from iRacing, I know they are having vehicle dynamics engineers to handle all of these feedbacks. So I trust all of their work and totally respect that. So I think what we should do is that we just genuinely, authentically, we just transfer what they want to convey to the device.
So what's your feeling on filters then after that? So let's say you minimize cogging.
Yeah.
But then what in ComSpit Link 2.0 there are filters, for example, or things you can change.
Yes.
What's your recommendation on that? Minimize it to start, or small changes, or?
So in terms of any changes to the wheelbase, I would recommend you can try each settings at one time, because you need to know what the slider is affecting, and you can go all the way, crank it up to the maximum, and try and see what's the difference. And you can go reverse to the minimum.
So this is what it does.
Yes. Yeah. Yes. So basically, you can know more about what slider is doing, and so you have maybe 5 sliders. Once you get to know what sliders really does to the system, you'll get better, and you'll also know better what is your preference and what you need.
Or you can watch one of my settings guides and I'll tell you, right? But just on this, you can see here with the magnets, does this dictate the strength also? How small can you get with a wheelbase? Like, could you make this wheelbase smaller by having less magnets, but then it would be weaker?
Smaller?
Yeah.
So here's the thing. As you can see, the size of the motor is exactly the same on our 3 models, which is Platinum and Arrest. Also, we have Arrest Apex. So the size, the diameter of the motor is the same. So what we are doing for 3 models is that Platinum is with the thickness of this thickness, and we just reduce the thickness.
Oh, okay.
Yes, and
thickness. Okay.
But there are still some difference between just the offline things we are talking about previously. So they are not always the same. We still need to adjust the design of how the stator and the rotor is aligned, because when you have lower capacity of your wheelbase motor, it feels completely different.
Okay.
And you need to adjust the amount of difference and to get the best out of what you're having.
Okay. So really, it's very interesting. So you change the thickness, but that dictates kind of the form of the wheelbase. I've seen some cylindrical wheelbases. It kind of makes sense now. I can see here you have the kind of extension for stability, right, and mounting.
Yes.
So yeah, it's interesting. There's maybe not too many ways you can style a wheelbase that much, maybe, because there's so much function of the direct drive.
Yes.
And this is the incredible technology that makes sim racing. It's been the big step up in sim racing in the last few years. These kind of motors and wheelbases becoming more accessible for more drivers.
Yes.
But yeah, what an amazing insight. I really appreciate it.
Thank you.
And ConSpit always coming up with crazy stuff. So let's see what's next.